Welcome to Cookie's Maths and Science Hub. Today, we'll be looking at sketching and determining basic exponential functions on the Cartesian plane. Before you is the standard form of exponentials. That is, f of x is equal to ab to the power of x take h plus k. Our a value is often called our initial value and provides our y dilation factor. Our k value provides our horizontal asymptote value. Now, asymptote is simply a word we use to describe something that is a straight line that constantly approaches a given curve, in this case, the curve of our exponential graph, but does not meet at any infinite distance, meaning those two lines, the lines between our exponential graph and the asymptote, will never meet one another. Finally, we have our h value, which is our x translation as well. Let's look at this on a graph now. On this graph before you, you can see how we have our horizontal asymptote and our exponential line, which is a curved line that comes down to go straight along, but never meet that asymptote on that horizontal axis. We'll be looking a bit further into how to draw these graphs, as well as how we can determine from the graph an equation. For this video, we're just going to focus on the core function of the exponential function, often known as the parent function, which is just y equals ax plus k. Effectively the function without all the dilations and translations. This is much simpler and will serve as a good foundation for determining from graphs the equation and using the equation to graph exponentials. We'll have a whole video later on that we'll release later in the year or next year that will look at translations for a lot of different graphs, from quadratics, exponentials, logs, logarithms, etc. So let's look at an example. We've been told to graph f of x is equal to 5 to the power of x plus 1. Now straight away from this, we can see our k value, or that 1, is our horizontal asymptote. So that means we're simply going to have 1 as the line that can't be crossed, that line where the straightest bit of our exponential runs across but never meets. It's important that you never draw them meeting. Now, the two things you need to find when graphing an exponential are f of 0, or effectively substituting 0 in for the x, and f of 1, which is just simply substituting 1 in for the x. These allow us to determine a couple of different things. First of all, finding the y-intercept is always important in any graph, and setting x to 0 will allow us to do that. Secondly, f of 0 and f of 1 allow us to determine whether it is a positive or negative slope. This means whether the curve goes up or the curve goes down on our Cartesian plane. If f of 1 is less than f of 0, then the slope of the graph is negative. If f of 1 is greater than f of 0, the slope of the graph is positive. And I've put that up there in its own box to remind us as we're working through this as well. Just to clarify, again, f of 1 simply means substituting 1 in for our x value. And f of 0, 0 for our x value. So, if we substitute 0 in for our x value in this equation, we'll have 5 to the power of 0 plus 1. Remembering from our exponentials, anything to the power of 0 is simply 1, meaning we'll have 1 plus 1, which will give us 2. As I said, this also serves to determine our y-intercept, so we know our y-intercept for this equation will be 2. Now our f of 1, that is 5 to the power of 1 plus 1, is simply going to be 5 plus 1, which gives us 6. As our f of 1 is greater than our f of 0, we'll have a positive slope. Now, it's often implied and much suggested that you find another additional point within your graph, as this will help you refine exactly your drawing. For this one, we're just focusing on those core steps. So you can see I've got my horizontal asymptote, and whenever you put that on the graph, you need to make sure you label it, as it's a clear foundational part of the graph. And then I've drawn my exponential curve. Now we have 2 points we can use. We have our y-intercept, and we also know that when x is 1, y equals 6. And I've drawn that to match that on that side there as well. Okay, same thing again. We've been told to graph f of x is equal to negative 2 to the power of x, subtract 2. Straight away, we can see our k value is negative 2, so our horizontal asymptote is going to be negative 2. I'm going to put that on the graph straight away for this one. Now, once more, we need to find our f of 0 and our f of 1, determining which one's greater and which one's lesser, as well as using our f of 0 as our y-intercept. Remembering f of 0 is simply putting 0 in for our x value. So our f of 0 in this case will become negative 2 to the power of 0 minus 2, which is going to give us -1 subtract 2, which will give us -3, meaning our y-intercept is -3. Now our f of 1 value, or where x equals 1, is going to be -2 to the power of 1 subtract 2, meaning we're going to have -2 take 2, which is going to give us -4. This means you can see our f1 this time is less than our f of 0, meaning we're going to have a negative slope. That means the curve's going to be curving down. Once more, it might be suggested that you find another point to make sure your line is drawn perfectly. But you'll see here, I have drawn it, making sure that more straight bit of my exponential does not touch the asymptote, coming down through our -3 and moving downwards as it is a negative sloped exponential. For this last example, we're going to look at determining a function from a graph. And as I said, we're just focusing on that basic function of f of x is equal to b to the power of x plus k. We're not worrying about any dilations at the moment. So our function over here, straight away we can see its asymptote is y equals -1. So we're going to know that's our k value straight away. We can see that it goes through the y-axis at 0. So our y-intercept is going to be 0. And we have a point at 1, 1 that has been labeled, knowing that it passes through there, which will be helpful to us later in the equation, trying to fix up those last few parts to solve. So we also see that it has a positive slope. So we know that f of 1, or that is when we put 1 in for the x value, it should be greater than 0 because our f of 0 or our y-intercept is 0. Given all that information, we have f of x is equal to b to the power of x minus 1, because we still don't know what that b is. So at this point, we're going to need to substitute in a value. Thankfully, the graph's given us one, which is very helpful. So we can substitute in our point 1, 1, which is effectively our f of 1 as well, meaning that we should know it should be greater than 0, given that we have that positive slope. So writing that out, we then have 1 is equal to b to the power of 1, subtract 1, bit of algebraic rearrangement. And if you're a bit uncertain on that, it's always good to practice. Check out our video on the topic. That -1 comes across to the left-hand side, becomes +1, so that becomes 2 equal to b to the power of 1. And because b to the power of 1 is just itself, that means b is equal to 2, which gives us f of x is equal to 2 to the power of x subtract 1 as our function for this graph. Thanks for watching. Hopefully now you have a foundational understanding of exponential functions and how to graph them, as well as determining more simple forms from a Cartesian plane as well. Be sure to like and share this video and leave a comment below with anything you'd like to see in the future. Be sure to subscribe to the channel, and we hope to see you again soon.